Okay, let's look at how to see pictures of alpha and beta errors. So in this is a process, and obviously this process is a normal distribution. So it's centered at 12. So the top of this happens right at 12. But there's variability because every process that produces anything has variability. So we're going to say the standard deviation is 3. And you can see I can play with this number. I can make it have more variability. I can have less variability. I can get rid of variability. So anyway, this is my process. And then as an input, I'm saying that these are my control limits. So I've established a control limit at 6. That's what this line is. And another control limit at 18. That's what this line is. And what these lines represent, it breaks this into 3 regions. In this region, where this arrow is, in this region over here, it's actually this region and this region. This region plus this region, if I ever would get something on this side of the control limit or this side of the control limit, I'm going to say my process, something has changed. If I get something between these two lines, between 6 and 18, between these two lines, I'm going to say that my process hasn't changed. So these become criteria that I decide if my process has changed or not. So what does that mean from a type 1 error? Remember, a type 1 error is when there hasn't been a process changed, but there is a chance that my test will say something has changed. So here's my test. My tests are that if it's between these two lines, my process is okay. If it's outside of that, the process has changed. That's what I'm going to say. That's my rules. Well, let's just look at the process. The process starts way over here, and it goes up, and it goes down. So most of the time I'm in this world, but occasionally I get a number over here, which is on this side, and occasionally I get a number over here, which is on the right side. So even if my process doesn't change, occasionally I'm going to pull a number, either low or high, that are going to be outside of my control limit numbers. And then because of my rules, I would say, hey, my process has changed. But it hasn't. It hasn't shifted or anything. So what is the area here plus the area here? That's my type 1 error. That's a probability that I will say my process has changed when in reality I just happen to pull a really high or low number. Well, that's what this area is, and it's about 5%. Now I could do things. I could make this smaller by making these wider. I went the wrong way. I can make these wider, and then my probability of having a type 1 error is smaller because I widen my control limits. And now I'm down to 2%. Or I could make them narrower and it would get bigger. And we don't want to have type 1 errors very often, but type 1 errors are related to type 2 errors. And when you try to make type 1 errors really small, the type 2 errors can get bigger. So let's talk about a type 2 error now. Let's get back to what we had. We have a type 1 error of 5%. Well, then now let's look at the process changing, because in a type 2 error occurs when the process has shifted. So let's get a new process that was originally centered at 12, and let's let it move over where it's now sitting on 15, or let's make it 18. Okay? So my process was here, the red line, but because of something happening, I'm now getting a higher number. Now I'm centered at 18 with the same standard deviation. So my process has shifted from the red to the purple. Now the issue is, am I going to be able to detect that process, that shift? Because it has shifted. We're going to say it has shifted. Well, look what happens. Remember, my rules are still this vertical line and this vertical line. So if I'm within this area, I want to say my process is okay. If I'm in this side or this side, then I'm going to say my process has shifted. So look at all of the area of this chart that is inside of this. And I can show that. There. Remember, my process has shifted, and the area between this line and this line is this number. So now I now have a type 2 error, of 50%. A type 2 error occurs, and what that means is that my process has shifted, but because of my rules, I didn't detect it. So that's a dangerous situation where my process truly shifted from here to here, and 50% of the time I won't know it. I'll just say, no, nothing's happened. Well, that's a big deal. So how can we reduce that? How can we reduce that? One way that we can reduce that is to make our type 1 error bigger. So if I would move my control limits, these numbers, the 6 and the 18, if I would tighten those up, so let's tighten that up to, let's go in 2 on each side. 8 and 16. So what I've done is narrow my limits, and look what happened to my type 1 error, type 2 error. It went from 50% to 25%. So I'll detect that quicker. But look what happened to my type 1 error. It was 5%. Now it's 18%. So you're always trying to decide what your rules are going to be to detect what type of shift and the willingness of these. So that's how type 1 and type 2 errors exist. It's based on the process, it's based on your rules, and it's based on what you think the process, how big a shift do you want to be able to detect. Okay, thanks.